Let's talk a little bit about what we know about the composition of the moon. What does it look like, and what actually is it made up of? First off, I did mention that the Apollo astronauts, when they first went to the moon, the most precious cargo they brought back, aside from, of course, themselves, was a collection of moon rocks. And these moon rocks answered this big question, and the question was the moon an add-on feature that came later, or was it an integral part of planet Earth? And because of the fact that, and these are a collection of pictures of actual moon rocks, they found that it's almost the identical chemical composition for the Earth and the moon, which is evidence for that Theia collision hypothesis. The Earth is denser than the moon, and we believe this is due to the fact that the Earth got most of its iron and nickel sometime after its collision with the moon. When the Earth was very, very molten and hot, there was the moon, there was the Earth, and after the moon had been created, we think that there was another body made of mostly iron and nickel, a meteor of some sort, that came in, collided with the Earth, and this heavy iron and nickel sunk to the center of our planet and gave us our iron and nickel core. The moon does not have that same sort of iron and nickel core. It was definitely not the size of the Earth's, and we believe that this was an additional collision that created that quantity of iron we see on our planet. How big is the moon? The moon is about 1/6 the size of the Earth, and because of its composition of mass and diameter, it has about 1/6 Earth's gravity. So if you went to the moon, you would actually weigh less. So if you're 120 pounds on Earth, you'd be 20. If you were 180 pounds, you'd be 30. If you were 300 pounds, you'd be 50 pounds. And I remember being a kid and watching Apollo astronauts bounce around on the surface of the moon because an astronaut, let's say he was 200 pounds and had another 150 pounds of equipment on him. And so he's got 350 pounds and he's bouncing around like a little jackrabbit. And this is due to the fact that they just didn't weigh very much. So that's why they were able to carry the massive life support systems that they needed when they got to the moon. One of the other things that's really fascinating about the moon is there is a light side and there is a dark side, just like the old rock and roll album, The Dark Side of the Moon. The side of the moon that you and I see all the time is the light side of the moon. The far side of the moon, unless in your lifetime you have the privilege of getting into a rocket ship and flying around the backside of the moon, in person, you're never going to see this. And that is because the moon is what is referred to as being tidally locked. And the moon only shows us one face. So through time, Earth's gravity has actually caused the moon to rotate at such a rate so that it only shows us one face at a time. And that's called tidal locking. As the moon goes around us, yes, this is the Earth, the moon does rotate, but it rotates at exactly the right speed so that we only see one side of the moon. We only see one side all the time. So its rate of rotation and its rate of revolution are matched. Now, how in the world did this occur? I'm going to let a little animated video do a little bit more explanation of that.